Hi, I am Ambareesh. In this talk, I will present our work on co-optimized region and layer selection for image editing based on StyleGAN and CLIP. In order to edit an image for a given text prompt, it is important to identify the corresponding region of the image and also choose an appropriate set of StyleGAN layers controlling the relevant image attributes for the required edit. In this paper, we address the problem of automatically identifying the region along with the correct set of StyleGAN layers in a co-optimal way. To achieve this, we propose a novel multi-layer feature blending strategy that improves the clean FID score and reduces the training time when compared to previous works. Please take a look at our paper and watch rest of the video for more details on CoralStyleCLIP. Our approach belongs to the family of StyleCLIP based methods. All of these methods aim to find a direction in latent space which yield edits specified by the fixed input text prompt. Two approaches used to achieve this are global direction and mapper. However, results generated by these methods often result in modification of image outside the region of interest. To mitigate this issue, Feed proposed an attention-based method that blends features at a handpicked layer to retain edits only in the region of interest as predicted by the attention mask. In our paper, we aim to retain the simplicity of ideas based on global direction and mapper, while aiming to achieve high fidelity in our edits similar to Feed. Our CoralStyleCLIP method employs a novel blending strategy to automatically learn the correct regions and the correct set of layers that correspond to the fixed input text prompt. We refer to this as multi-layer feature blending strategy. We demonstrate a total of 4 variants of our method, resulting from 2 different ways of learning latent direction in line with previous works, and 2 different ways of region selection. We first present the blending strategy, followed by the region selection strategies. Finally, we present the loss formulation used in our approach. Our blending strategy is employed at every layer of the StyleGAN network using the predicted per layer masks and the predicted latent direction. At each of the StyleGAN layers, we feed forward the feature obtained at previous layer into a branch that produces the feature using original latent code W depicted in green and into another branch that produces feature using the edited latent code W plus delta depicted in blue. The green and blue features are blended using a mask predicted by a region selection strategy such that the blended feature retains edits from the blue feature in the region of interest. This blended feature, which is depicted in orange color, is fed into the next layer. During training, our blending strategy propagates gradients into region selection and latent direction modules. In one of the variants of CoralStyleCLIP, we propose segment selection approach for region selection and global direction for learning a latent direction. The segment selection approach selects a set of segments from a pre-trained network for the fixed input text prompt at every layer of StyleGAN network. This is achieved by constructing per layer masks based on the matrix E, which is composed of confidence values that indicate if the segment is part of the region being altered at the given StyleGAN layer. Although the proposed segment selection approach is very fast, it has some limitations due to the limited control over the area of selected region within a segment. Hence, we propose another approach for region selection by using convolutional attention networks. In the case of convolutional attention network, we predict per layer masks based on the feature from StyleGAN network by learning a dedicated per layer attention network for the fixed input text prompt. As demonstrated in the results section, this approach yields improvements in the edit quality in comparison to segment selection approach. Similarly, we also demonstrate another variant of latent direction based on the mapper network. Unlike global direction, latent mapper module learns a customized edit direction for the input image. The only trainable components in the proposed approach are the modules that belong to the latent direction and region selection. We train these modules using the shown loss formulation consisting of various losses. Clip loss maximizes the similarity between input text and the edited image. L2 loss limits the latent edit direction in W space. We also impose an area minimization regularizer to learn compact regions corresponding to the edits. The total variation loss term enforces smooth variation of confidence values among adjacent pixels in the mask. Finally, we make use of ID loss for real-world face images to preserve the identity of original image in the edited image by using a pre-trained arc face network. Here are the results of the Coral method on proposed region selection strategies. In the case of segment selection approach, we used a pre-trained segmentation network trained on 5 semantic segments. For the text prompt surprised, our method accurately selects the segment that corresponds to the eyes and mouth region and automatically selects 6th and 7th StyleGAN layers. Similarly, for attention network, our method selects the relevant region and relevant set of layers corresponding to the text prompt, blue eyes. These results are in line with the observation that earlier StyleGAN layers control structural aspects of the image and later StyleGAN layers control appearance aspects like color. Here are some additional results. In all of these results, Coral edits the image within the relevant areas. For example, the background remains unaltered across all the edits. We benchmarked our approach against the recent state-of-the-art methods in this area. In the case of feet, we demonstrate results for blending at layer 7 and 13. Firstly, StyleCLIP and StyleMC are able to produce an edit according to the text prompt, but they also alter the regions of the image that do not correspond to the text prompt, such as the background. Feet is able to generate high quality edit when the correct layer is manually handpicked. Our proposed CoralStyleCLIP variants consistently produce a high quality result because it can automatically select the layers and regions accurately. Our quantitative results of training time versus clean FID show that our segment selection approach achieves a low FID edit quickly in under 15 minutes of training, and our convolutional attention network based approach obtains state-of-the-art FID score when compared to previous works. This slide studies how Feet and Coral perform on more challenging multifaceted prompts where the edits come from multiple StyleGAN layers. Our proposed method can generate edits with high fidelity owing to the ability of the method to blend features at any of the StyleGAN layers. In summary, our proposed multi-layer feature blending strategy selects regions and layers accurately for a given input text prompt, and our segment selection based Coral variant is able to achieve high edit fidelity in just 15 minutes of training. Thanks for your attention. Here are some additional results on sketches and cars.